All right, this is lesson 3. We're going to be talking about the tilted squares using those geoboards again, and then square roots of non-perfect squares. So let's take a look at the opening exercise. It says, given the area of triangle is A equals 1/2 base times height. So here's your formula. Find the area of triangle A, triangle B, and triangle C. So let's look at triangle A. We're finding area, so we're going to use 1/2 base times height. In order to do that, we need to know the base and the height. So this looks like it's 3 units. The height is 3 units. So 3 and 3. So we're going to do 1/2 times 3 times 3. That's 1/2 times 9. Half of 9 is 4.5. And we don't know the units, so we're just going to label it units squared. So that would be for triangle A. Triangle B is still a triangle, so we're still going to do 1/2 base times height. Our base looks like it's 1 unit. Our height looks like it's 2 units. So 1/2, 1 times 2. 1/2 times 1 times 2 is 2. So half of 2 is 1, and that's units squared. All right, triangle C, we're going to do 1/2 base times height again. So our base, count it up, that's 4. Our height is 5. So 1/2 times our base, which is 4, our height, which is 5. Let me move this up so you can see it. So 1/2 times 20, half of 20 is 10. All right, so that's just some basic triangles, and there's a reason why we just did that. Let's turn to the next page. We're going to go to example 1. And we're going to start finding the area of a square that is tilted. So it says, what is the area of this square? Now, we can't figure out this diagonal piece. We can't figure out what that length is. So what we're going to do is I'm actually going to draw a box around it, because if I draw a box around it, then I know how to find this area of the whole thing. And then I notice that there's 4 triangles, and I'm labeling them right now. So if I know the area of the whole thing, I can just subtract the area of these 4 triangles. So if I call this square A, I know that's really hard to see. Okay, I'm going to call that square A. The whole thing, I'm going to call square B. So as I'm referring to this, that's square B. So A is the shaded part, B is the whole big drawing. So what I know is that I could take the area of B, which is the outer edge, and that would equal the area of A, the shaded part, plus the 4 triangles. Now let's look at these 4 triangles. Each triangle has a base of 2 and a height of 3. Base of 2, height of 3. Notice that that's the case for all 4. So I really just multiply 4 times the area of the triangles, because they are all the same. So in order to get the whole thing, I'm adding the shaded plus each individual one. Now, what that means is to find the area of A, which is the shaded part, I could really take the area of B and subtract the 4 triangles. That's just another way of thinking about it. So let's figure out how to find square B first. So square B, we're going to find the area. Now remember, formula is A equals side squared. We did that yesterday. So let's look at what the length of a side is. 1, 2, 3, 4, 5. So the side length is 5. So 5 squared gives us 25 units squared. So that's just square B. All right, so now we have to find the area of each triangle. Okay, so let's find the area of the triangles. Okay, that formula, remember from the last page, was 1/2 base times height. They're all the same, remember, so we're going to do 1/2. The base is 2. The height is 3. So 1/2 times 6 is 3, and that's units squared. Now, if you're talking about all 4 triangles, You just have to multiply that by 4. So 4 times 3 is 12 units squared. So let's find just the area of square B, or square A. Square A. Remember, we're going to take the area of square B. We're going to subtract the 4 triangles. Okay? So, area of square B we found to be 25. And then we're going to do 4 times 3. So that's 25 minus 12, which is 13 units squared. So the area of the A we found by finding the whole area and subtracting the triangles, which gives us 13 units squared. So what is the measure of the side length? Now, from yesterday, we learned that when you have a side length of a square, it's equal to the square root of the area. That's how we found it. Remember, we did side length was x, so we take the square root of x squared because x squared is the area. So the square root of the area is 13. So my side length would be the square root of 13, and that would be units. All right, so let's go to example 2. It says, is the area a perfect square? In this case, is that a perfect square? No, because remember it was 13 units squared. So that's not a perfect square. It says, is there an integer that you can square to get this? So no, nothing times itself gives you 13. So which two perfect squares is the area closest to? Well, 13 is close to what? What times what gives you something close to 13? Well, 3 times 3 gives you 9. But 4 times 4 gives you 16. So it's actually in between 9 and 16. So place the square root of these perfect squares on the number line. Well, let's think about this. I'm just going to number these 1, 2, 3, 4, 5, 6, and 7. Now remember, the square root of 9 is 3. The square root of 16 is 4. So that means because 13 is between 9 and 16, that somewhere in here has to be the square root of 13. It's going to be closer to 4 because 13 is closer to 16. Now, determine which integer the side length of the square is closest to. So the side length, because it's closer to 16, the area is closer to 16, the side length is going to be closer to 4 units. All right, example 3. All right, we're going to try this all again. We have a square here, so we're going to call that A, just like we did before, and we're going to draw a box around it. We're going to call that square B. All right, so let's start with the area of square B, and then we'll subtract all of the triangles. So A equals side squared. The side length is 2, so the area is 4. All right, let's do the triangles. We're going to do A equals 1/2 base times height. So 1/2, now the base of each triangle is 1. The height is 1, so 1/2 times 1 times 1 is just 1/2. And that's units squared. Now there's 4 triangles. So we're going to take 4 and multiply by 1/2, which gives us 2. So to find the area of square A, we're going to do square B minus 4 triangles. So that's 2 units squared. All right, side length. We are going to do it in square root notation. Remember, I'm just going to remind you that side length is equal to the square root of the area. So we're going to take the square root of 2, and that would be 2 units. Now, what is this close to? Because 2 is not a perfect square. So since the area, which is the square root of 2, that's going to be close to 1. 1 is a perfect square. Remember, the square root of 1 is 1. And 2, I'm sorry, I should say 4. We're talking about the area. So the area is 4, which the square root of 4 is 2. So because it's between 1 and 4, that means the side length will be between 1 and 2. So side length is between 1 and 2. It's going to be closer to 1, though, because 2 is closer to 1. All right, last page. Now I'm going to have you do these 2 problems on your own. When you're done, I'm going to have you just check those answers and make sure they are correct. These are exactly the same problems that we were just doing. Okay, so go ahead and pause the video now. All right, so I'm going to call this A. I'm going to go all the way around. I'm going to call that B. So let's talk about square B first. We're finding area, which is side squared. So count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 squared is 100. And that's units squared. All right, let's do the triangles. 1/2 base times height. So 1, 2, 3, 4 is your base. 1, 2, 3, 4, 5, 6 is your height. So that's half of 24, which is 12 units squared. Now remember, we want 4 triangles. So we're going to take 4 times the 12, which is 48. So square A is going to be square B minus the 4 triangles, which is 52 units squared. All right, now let's talk about side length. Remember, side length is going to be the square root of the area. So that's the square root of 52. Now, what is the side length closest to? Well, the area is closest to 49, my perfect squares, and 64. Now, just remember the square root of 49 is 7. The square root of 64 is 8. So that means that the side length is closest to, well, 52 is closer to 49, so it's going to be closest to 7. All right, exercise 2. Okay, this is square A. So I'm going to draw the box around it. I should say a square. These aren't very straight lines. All right, so square B first. So area is side squared. Count it off. 1, 2, 3, 4, 5. So 5 squared is 25 units squared. All right, let's do the triangles. So 1/2 base times height. 1/2 times the base is 1. The height is 4. So 1/2 times 1 times 4 is 2. All right, so 4 triangles is going to be 4 times 2, which is 8. So now let's do square A. That's going to be the 25 from square B minus 8, which is 17 units squared. So that's square B. So side length comes from the square root of the area. Square root of the area is 17. That would be units squared. Actually, just units. It's a side length, not an area. All right, so let's talk about what it's closest to. Well, 17, so the area, is close to what 2 perfect squares? 16 and 25. Now remember the square root of 16 is 4. Square root of 25 is 5. So that makes the side length closest to, now is 17 closer to 16 or 25? It's closer to 16. So that means the side length is going to be close to 4 units long. All right, I'm going to have you practice this using the problem set, and we'll go over that in class tomorrow.